For this antenna, I went and purchased a square bit of tubing from the local hardware store, 25mm by 25mm. It came as a 3 metre length. There you can see a bit of it here on the bench. And I also purchased from the same hardware store some 10mm aluminium tubing. The 10mm tubing cost around about $24, so it wasn't too bad. And that will give me all of the 10 elements. I've already cut some here, as you can see, and the box section cost around $39. It wasn't quite long enough, so I went and purchased some 20 by 20 or 19 by 19.5, and I'm going to put that in the end to give me an extra 650mm, which is what I need for the total length of the boom. So here's the first hole, which is for the reflector. It's a 10mm hole, slightly enlarged because the actual tubing is slightly over 10mm, and a small hole for a screw to keep the rod pinned. I'll just put the reflector through there, and I'll show you how I'm holding the whole thing together. So here is the screw, just a little stainless steel screw, and it will just pick up the hole in the tubing. There it is there. Once that's in, that's quite rigid, and using the stainless steel it's probably better than anything else. With the aluminium, probably put a bit of conductive grease over the top or something if I find that the dissimilar metals cause a problem, but I usually find stainless steel and aluminium are not a big deal. So that's the reflector. So I'm up to the section now where I've got to do direct to 6, so I've got to put a 10mm hole through there and line things up here. Okay, this particular 10mm tool bit is actually an end mill, but it doesn't have the teeth. Do not go all the way to the center. There's a clearance in there, so you have to drill a small hole so that otherwise there's no you're trying to cut metal without a tooth, basically is what I'm trying to say. So we'll set that up now, and we have that pretty right. We'll spin it up and see what happens. Now it looks pretty right, so I'll take that through. No speed. And we can go right through. Now we know that we now know that hole is straight because I've lined it all up on the mill vise there, which has been carefully set up to be the right level with the rest of the machine. So that's the hole drilled, pretty quick and easy. I haven't cut Director 5 yet, so I'm ready to do that. Director 5 is 92.1 centimeters. So I'll measure that up and now cut that. So I've now clamped the rod tubing in the saw. I'm using a 100 tooth PCT blade. It's about 10 inches, designed for cutting aluminium. So that's now. So now I'll just clean the edges up on this bench grinder using the grinding disc, and that just takes away the sharp edges. So now we see if the tube goes through. I usually find that the first hole's not too bad due to the slight movement of the mill tool, but the second holes can be a little bit tight. So with this reamer, we just give it a little bit of a rub and make sure we can get it in and out without too much effort. You don't want it too loose. Well, that's pretty good. So that goes in and out. Now I've got to mark the middle of the tube and put a little hole in where I expect the screw to go through, which is going to go through that hole there. So let's give it a bit of a punch. Okay, now we'll take it over to the drill press and put a 1.5mm hole. Just bung that in here somewhere, nice and vertical. We're only putting a hole in the top of the tube, so it doesn't matter if you're a little bit out. We're not going straight through. Good. So let's see how this goes. Get in there, and you'll see these two little marks. They're the edge of the tube, and the black line should line up with that black line. So we'll now just grab one of the little stainless steel screws. Yep, it's about there somewhere. You'll feel it. When you get close, you can feel. That's it there. We're in the middle of it. Okay. So that's Director 5 done. Next one will be Director 6, but I'll move on and I'll show you when I've got the driven element all set up. The elements for the 10 element beam have now all been cut. At one end I have all the elements flush against a piece of timber. You see there. And at the other end we can see the variation in length between the reflector, driven element, and up to the 8th director. There we go. For the gamma match, I'm using this particular setup off the web. There are a number of different setups, but I found this one's not too bad. I had to move the tap point further out. Mine's a 10 element beam, whereas I think this was only for a 5 element, so the impedance as seen at that point is different with the 10 elements and the placement of the first director, so I needed a different step up ratio with the gamma match, but I'm more around about 150 millimeters. Here's a closer look at the connecting bracket between the driven element and the gamma match. I've used a piece of 8mm thick aluminium, drilled a couple of 10mm holes for the tubing, and some 5mm holes for the nuts, the bolts you see there, and then those holes were tapped for 6mm, and you'll see the bolts are stainless steel with a lock nut and a lock washer, so it's all nice and firm. So here's the completed beam on the floor of the workshop, sticking out. It's ready to go up on the tower. Just thought I'd give you a quick look. Down there you'll see the gamma match. Here's a closer look at the gamma match. The capacitor made out of RG213, the inner section, which slides in and out of this 10mm tube, the shorting bar, and I've tried to protect the connections using some hot melt glue. The hot melt glue comes from this this particular Ryobi machine. The glue is very good quality. I found it's quite good. I've tried it on some outdoor stuff to see if it's resists the weather, and seems to be holding up at the moment. And for the rest of the beam I've used stainless steel fasteners such as these screws to hold the elements in place.